I'm Stephen Elliott, President and Life Scientist for Coherence LLC, the new science of breath. Today I'd like to share with you the brief presentation, Coherence, the Big Picture. I originally recorded this for the first ever Coherence Conference, which occurred in Bridgeport, Connecticut last week, organized and chaired by Dr. Mark Filippi. From Wikipedia, coherence is a property of waves that enables stationary interference, such that if we have two perfectly identical waves and they collide, they will negate each other in every regard. More generally, it describes all the properties of the correlation between all of the physical quantities of a wave. And as we're thinking of wave action and coherence of those waves as it relates to the human body, the primary quantities of concern are amplitude, phase, and frequency of those waves being observed, whether they are the movement of the diaphragm, the movement of the air in and out of the body, the movement of blood through the circulation, or the variation in heart rate, etc. Also, coherence can be observed in the brain waves. When we look at, think of wave phenomena in the body, it is the diaphragm which is the primary motive force behind the creation of waves in the body, and ultimately behind the coherence of wave action in the body. In that coherent wave-like action of the diaphragm results in coherent wave-like action of the airflow, of the blood flow, of the heart rate, etc. The diaphragm does this by moving up and down, and in so doing modulating the internal volumes of thoracic and abdominal cavities. And as their volumes are modulated, their internal pressures are modulated, and as such the airflow is modulated, airflow in and out of the thoracic cavity, blood flow in and out of both the thoracic cavity and the abdominal cavity. And with this, there's a changing autonomic emphasis which occurs with every cycle of respiration, especially when respiration is slow, deep, and rhythmic. An outcome of autonomic emphasis is changes in the heartbeat, both its rate and its output. And if we plot the heartbeat rate as we know, we end up with what's known as the heart rate variability cycle. And therefore changes in heartbeat rate can be observed very readily as it changes with respiration. This is in keeping with the phenomenon of respiratory sinus arrhythmia, which I like to refer to as respiratory sinus arrhythmia, in that arrhythmia connotes a pathology when in fact it is the absence of the arrhythmia that is pathological. The body also demonstrates wave-like action in its movement, for example walking, and the body itself, including the spine and the limbs, exhibit wave-like physical structures and demonstrate resonance. So where there is wave phenomena in the body, the potential exists for those waves to demonstrate coherence or not. Here it's best to think of a spectrum with coherence on one end and chaos on the other. I like to refer to the diaphragm as the Tai Chi Diaphragm, in that it is the job of the diaphragm to create and maintain dynamic equilibrium in the body. And again, it does this through its upward and downward motion, which can be slow, deep, rhythmic, coherent, or it can be fast, shallow, arrhythmic, and incoherent. Ultimately, the coherence of all of the waves, the product of this wave action, reflects that coherence or not. I like, again, to refer to this at large as the internal pendulum, in that the body is arranged in such a way, the nervous system is arranged in such a way that there's a subtle interplay between sympathetic and parasympathetic systems, and between many of the activities going on inside the body, including the movement of air, the movement of blood, the changing of the heart rate, the changing of brain waves, etc. A couple of interesting questions. What is the range of the swing of this pendulum? Is it very small, or is it quite large and robust? And is the motion of the pendulum coherent or incoherent? Can a pendulum swing? Can it maintain its momentum if the action of it is incoherent? No. It will gradually come to a stop. This is not unlike pushing a swing on the playground, and instead of pushing it rhythmically, pushing it arrhythmically. In time, it comes to a stop. So ultimately, the range of the swing of the internal pendulum is a function of the rhythmicity or the coherence. The diaphragm accomplishes this task through, again, modulating the two primary sealed cavities of the torso, the thoracic cavity above and the abdominal cavity below. And as it does so, it mediates both volume and pressure in an alternating fashion. We'll find a very elegant arrangement. So upward movement of the diaphragm decreases the volume of the thoracic cavity and thereby increasing the pressure in the thoracic cavity. At the same time, as the diaphragm moves up, it increases the volume of the abdominal cavity and thereby decreases the pressure in it. And of course, the opposite effect occurs as the diaphragm moves down. So again, referring back to our Tai Chi diaphragm, there's a opposite effect in abdominal and thoracic cavities as the diaphragm moves upward and downward, yielding this dynamic equilibrium that I referred to. If we look at the next layer of the onion, we'll see that the body is arranged in a very elegant fashion. Above the diaphragm in the thoracic cavity, we have principally the heart and the lungs. And below the diaphragm in the abdominal cavity, we have primarily the gut. Both of these organ systems are controlled by the autonomic nervous system. That is, sympathetic nerve endings on one side and the parasympathetic function, or the vagus nerve, on the other side. And as the diaphragm moves upward and downward, they're controlled in such a way that their behavior alternates. Regarding the heart, sympathetic nerve endings secrete norepinephrine, which activate adrenergic receptors, ultimately stimulating cardiac activity, causing the heartbeat to be faster, yet inhibiting gastrointestinal activity, that is, of the enteric nervous system of the gut. Alternatively, vagus nerve endings, which serve to inhibit or slow down cardiac activity, do that by secreting acetylcholine, activating cholinergic receptors, yet below the diaphragm stimulating gastrointestinal activity, again stimulating enteric nervous system activity. The long and the short of it is that as the diaphragm moves up, the heart slows down, and as the diaphragm moves down, the heart speeds up. As the diaphragm moves up, the enteric nervous system speeds up. As the diaphragm moves down, the enteric nervous system slows down. Can you think of why this makes sense. I'll offer that the primary reason is that it is the job of the large, strong, thick, robust diaphragm to help move blood through the body, through the thoracic cavity, and hence when it is moving upward, the heart slows down and its output increases. And as it moves up, the enteric nervous system gets busy. Why? Because there's no downward pressure on the gut to help move digestive matter along the intestinal tract. As the diaphragm moves down, the heart speeds up, having to do the job now of bringing venous blood flow back into the lungs, but the enteric nervous system slows down. Why? Again, because it assumes that the diaphragm will now press downward on the contents of the abdominal cavity, moving things along. And peristalsis can then slow down.